So we're starting quadratic functions, and under quadratic functions, we're going to do the roots of quadratic functions. So I wanted to prepare in the same slide to also add sketching of quadratic functions, but I don't want you guys to get confused. I want you first to understand the roots of quadratic functions. That's when we go to sketching. So what I've done is instead of teaching today quadratic, sketching of quadratic functions or quadratic equations, we're going to do it tomorrow on Wednesday, the same time. And then on Thursday, we're going to start a new topic. That other Monday, at least, we continue and move on like that. So, roots of quadratic functions. So the roots, when you talk about the roots of a quadratic function, we're simply talking about the answers that you get after solving a quadratic function. That's those two answers that you get are the ones that are normally called the roots. You remember in the previous slide, when you get two different answers, then we are talking about two different real roots. And then when you get two same roots or two same answers when you solve a quadratic equation, it simply means that the equation that you are solving had equal roots or repeated roots. And then when it has no solution, when the discriminant is negative, it's less than 0, then you know to say you have imaginary roots or it has no real roots. So in this case, we're going to be dealing with real roots and equal roots. So let's continue. So this is what I'm basically talking about. When you solve this quadratic equation here, you get to this part here, and then once you get to this part, the way you get to this part is just by factorizing any given quadratic equation. For those that cannot be factorized, you can use the completing the square method. Yeah, then the answers that you get, that you get are the ones that are called the roots of that particular quadratic equation. So this is what I'm just talking about. So however, you need to note some of the basic equations, and these equations are sometimes called identities. The reason why I call them identities, is because you just need to master them. Yeah, but if you want, you can try to factorize this, or if not factorizing this, try to use completing the square method, yeah, to reach these two equations that I'm talking about. So you should bear in mind to say a plus b is equal to negative b over a, and then a times b is equal to c over a. So these are basically the two important equations that you are supposed to know. You just have to know this. And then when you look at alpha, in this case, alpha is the answer that you get here. It's the number that is normally here, and then this beta is the number that is there. Then when you look at this negative b and this a, these are the numbers that you have here, the coefficients of x and x squared, yeah, respectively. So it also applies on this one here. So alpha times beta is just equal to c over a. So let us now try to look at examples. Yeah, because basically what I've explained is all that you need to know about these equations, or rather the roots of quadratic functions. So let us now try to take a look at examples. Yeah. So the first example that we have is this one here. It says the roots of the equations 2x squared minus 3x plus 6 is equal to 0 are alpha and beta. Find alpha plus beta, or alpha over beta plus beta over alpha. So this is very simple and straightforward. How do you solve such a question? So you first have to simplify this expression that you've been given here. You simplify this expression, or in other words, express this as a single fraction. How do you do that? So I'll write this here. I have alpha over beta. Yeah, you just pardon me with my handwriting. Anytime soon I'm buying the Wacom the thing that I'll be using to write what, to connect to the piece and then write properly things that you can see very soon, maybe in next week. Yeah. So when you have such a question, you first have to express this as a single fraction. First of all, you find the common denominator. The common denominator there, you just multiply alpha and beta there, meaning you are going to have alpha multiplied by beta. And then you divide this beta into that times alpha. You're going to have alpha beta. Sorry, you're going to have alpha squared because this and that will cancel, meaning alpha times alpha will be alpha squared. Then this will be plus beta squared. So now someone might be asking, do we have alpha squared, do we have beta squared on these two given expressions? Yeah, you might be asking yourselves, on this expression and then on this other expression, though it has been covered by what I'm writing, do we have alpha squared and beta squared? No, we don't have. Now where do we get them from? So you can do this alpha plus beta, and then you square these, because I know to say I have alpha plus beta, alpha plus beta, or let me just do this, let me just write them properly. Okay, over alpha, then we found to say this will be alpha squared, this will be beta squared. Then you have alpha beta down there. So from there, I was trying to demonstrate how you get this alpha squared plus beta squared. Of course, alpha times beta, we have it. It's here. So it's just a matter of replacing C over A where it's needed. C over A, which is C here is 6. So meaning 6 over 2. So our denominator there will be 6 divided by 2. So C over A will just be 6 divided by 2, which is 3. Then now, where do we get this alpha squared plus beta squared? So I said you square this alpha plus beta. You square this. So when you square these, you're going to discover that you have alpha times alpha there, you get alpha squared, plus alpha times beta, you get alpha beta, plus beta plus times alpha. So meaning you have 2 alpha beta. I'm pretty sure you guys know how to expand this. And then plus beta times beta, you get beta squared. Yeah, you're going to have something like this. So now since you have this, what we just need is alpha plus beta squared. So meaning we're just going to take these two alpha beta to the other side of the equal sign, which implies that we're going to have something like this. Alpha plus beta squared, and then when you take these two alpha beta to the other side of the equal sign, to be negative 2 alpha beta, then this is now equal to, we're just remaining with alpha squared and beta squared this side, alpha squared plus beta squared. So meanwhile there's alpha squared plus beta squared, we can replace with this, because in this expression I know to say I have my alpha plus beta, which is just this part, and then I also have my alpha times beta, which is just this part. So where there's alpha plus beta, we can replace with the things that I needed there. Alpha plus beta is just equal to negative b over a, meaning this will be equal to negative 3, negative 3 over 2. So here it's going to be negative times negative 3 there. It will be positive 3 over a, which is 2. And then everything has been squared, this square here. Then minus this minus. Then we write the 2 there. While it's alpha plus beta, you put c over a, which is 6 over 2, which gives 3. Yeah, so this is just equal to alpha squared plus beta squared. So this, when you square the 3 there, you get 9. When you square 2, you get 4. And then minus 6. So this is alpha squared plus beta squared. So this is 24, 9, which gives you some around, is it 15 over something? Yeah, I think negative 15 over 4. Negative 15 over 4. So this negative 15 over 4 is the one that you put there. So you put negative 15 over 4. Then when you simplify this, you get negative 15 over 12 as your answer. So this can also be simplified to negative 3 into 15 there is 5. 3 into 12 you get 4. So this is what you basically get. Alright, so we proceed. I want you guys to do this one. I've shown you how to do the first part there, and I've solved a lot of things, and the first part involves a lot of steps, including this same step here. So I want you guys to do 2 as part of your exercise, and then the roots of the equation x squared minus 2x minus 3 is equal to 0 are alpha and beta. Find the equation whose roots are 1 over alpha and 1 over beta. This is a very interesting question. The question is saying find the what? The equation whose roots are 1 over alpha and 1 over beta, given this. So what do you do when you see such a question? So this question has a lot of ways in which you can do it. Yeah, it has a lot of ways in which you can do this question. So you can, the simplest, I'll show you the easiest one. So the easiest one here is, we know to say for these two, 1 over alpha and 1 over beta, to be called roots, it means that at one point they are like this: 1 over alpha in brackets, and then also in brackets there x minus 1 over, this is what we just from discussing, yes, is equal to 0. So for these two guys to be called roots, it means that they were once like this. So now, how do you simplify such equation? So now, here's just a matter of multiplying. You multiply x times x there, you get x squared. X times negative 1 over beta, you get negative 1 over beta. And then there's an x outside. Negative 1 over alpha times x, you get negative 1 over alpha x. Negative 1 over alpha times negative 1 over beta, you get positive 1 over alpha beta. This one is equal to 0. So here we simplify this, we express it as a single fraction, then we factor out the x and the negative. We see what we're going to have. So when we factor out the negative, we'll remain with this in brackets. We'll remain with 1 over beta plus 1 over alpha. Then we also factor out the x, and then we have plus 1 over alpha beta, which is equal to 0. So now, you remember what I said, when you find such a situation in fractions like that, you simplify it, you express it as a single fraction. So here you find the common denominator there. The common denominator is alpha beta, and then when you say beta into alpha beta, you get alpha. Alpha times 1 is alpha. Same applies to the second part. Alpha into alpha beta is beta. Beta times 1 is beta. And then you put everything in brackets like that. Then you put your x outside. Then plus 1 over alpha beta like that. So this is equal to 0. So let me just divide this part here. We proceed here on top. So I'll write my x squared there. And then minus, while there's alpha plus beta, I'm going to put negative b over a. So this one I'm going to have negative 2 over 1. Negative 2. So negative times negative 2, I'm getting positive 2 over 1. I'll still get 2. Then over alpha times beta, meaning it's negative 3 times negative 3 over a, which is 1. So I'll still get a negative 3. So for the sake of not making a mistake, I'll put them in brackets like that. And then I'll say plus 1 over alpha times beta is just what we found here, which is negative 3. I'll also put this in brackets. Then this will be equal to 0. So here it's now just a matter of simplifying. X squared minus, so minus times minus there, you get a positive 2 over 3 x, and then this will be a minus 1 over 3, which gives you 0. So here if you want, you can multiply through by 3 for you to simplify it, meaning it will be 3x, it will be 3x squared, and then plus 2x minus 1 being equal to 0. So this is basically the equation they wanted according to this question. So when you try to find the roots of this equation, you discover to say these are the ones that are going to be your roots. 1 over alpha and 1 over beta are going to be your roots. All right, we proceed on the next question. So let us also try to look at this question here. Determine K so that the given equation will have the stated property and write the resulting equation. So I'll not do all the questions here. I'll leave some for exercise. Remember, on this one here, on this question here, you have this part as your exercise. I want you to do this as part of your exercise. And then here I'm also going to do 2 or 3 questions if time is going to allow, if not 1. Yeah. So we begin saying determine K so that the given equation will have the stated property. Yeah. So we can begin. It's the question is very simple. Let me just pick a question there which is at least not going to waste most of our time. All right, so I'll pick 2. Then apart from 2 there, I'll also pick maybe 3. If time is going to allow us, I'll also solve 3. Yeah. So if I'm going to solve 2 and 3, it implies that you're going to do 1 and 4 as your exercise. So I'm picking 2. So 2 is saying 4x squared minus 8k x minus 9 is equal to 0 has one root, and then the other root is negative. So what they mean is we know to say the roots that we normally have are alpha and beta. Now in this case it's saying it has one root negative of the other, meaning they are the same roots, same 2 roots. So here it's just a matter of understanding the mathematical language which is there. We are dealing with the same root, but the only difference between the 2 roots is that the one is the opposite of the other, is negative of the other. So in other words, we're trying to say the roots that we have here is what are just alpha and negative alpha. You can either use beta and negative beta or alpha and negative alpha. There's no problem. So these are the 2 roots that we have. So in other words, we're trying to say we have x being equal to alpha. We also have x. Let me just do this. We also have x being equal to negative alpha. So now from this same given equation here, we can find we know to say alpha times beta is nothing but equal to C over A. So in other ways, we don't have beta, we just have alpha and another alpha. So what we're going to do is, instead of writing alpha times alpha, we're going to write alpha times, we're going to write alpha, negative alpha times the other alpha there. So it should give us this. So here we're going to get negative alpha squared being equal to, so C according to this equation is negative 9, then over A, which is 4. So here to find our alpha, we just need to divide by negative. Yeah, you just need to divide by negative this side, even this side negative 1. So meaning you remain with alpha squared being equal to 9 over 4. So now what you do here to find alpha, you just find the square root, which is the plus or minus square root of 9 over 4. So this gives you plus or minus 3 over 2. Wow, so these are the 2 solutions that we have for alpha. So meaning these are the 2 roots that we have. So alpha 1 is equal to positive 3 over 2. And then alpha 2 is just going to be equal to negative 3 over 2. So this is what we're going to have as our values of alpha. All right, so now we continue. Let us also try to look at 3. Okay, so 3 here is saying okay, so 3 here is saying all right, so 3 here is saying 4x squared minus 8k x Oh, sorry. The question I'm from solving, we just found the values of alpha, and we didn't find the value of k. So now to find the value of k, you use alpha plus beta, alpha plus beta. So alpha plus beta, we know to say. So alpha plus beta, we know to say is negative b over a. So alpha plus beta, in our case, we only have one alpha, and the other alpha is what? Is negative of this other alpha, meaning what we have here would be alpha plus negative alpha instead of having alpha plus beta. Then our negative b there would be negative 8k, so meaning it will be 8k. So 8k would be our negative b there. Then our a there would be 4. So when you divide, first when you add this side alpha, this is just the same as writing alpha minus alpha. Then this one here is giving us 2k. So alpha minus alpha there, you get a 0. And then this one is giving us 2k. So when you divide by 2 this side, you also divide by 2 this side, you find your value of k being equal to 0. So our value of k there was giving us 0. So let us now move on to the third question, which is point 3 here, this one here. Yeah. So now this one is saying the roots of this equation, the roots of this equation has the roots whose difference is 4. This equation has the roots whose difference is 4. So what they are trying to say is, if one root is alpha, it means that the other root will be alpha minus 4, or the other way around. Meaning, when I say the other way around, it means you can also write 4 minus alpha. You still get the same answer. And then, so you can write them now in terms of roots. So meaning x is equal to this, or x is equal to alpha minus 4. So now from there now, we can try to find our alpha plus beta. So our alpha plus beta, in our case here, the other root that we have is this. So meaning where there is beta, we just have to replace with that. So instead of writing alpha, or let me just write it in full, alpha plus beta is being given by negative b over a. So meaning where there is beta, we're going to replace with alpha minus 4. So alpha plus alpha minus 4. This one will give us negative b. So negative b, our b here is negative 8k. So when you multiply this negative times this negative, we'll get just a positive 8k. Then over our a there is 4. So when you add these, you're going to have 2 alpha plus alpha there to be 2 alpha, then minus 4 being equal to 2k, like that. So now here what you do is you can keep this equation, or you can simplify it further before you even keep it. So this implies that we're having alpha, when you divide everything by 2 and then you take this 2k to this other side of the equal sign, so meaning we're going to have alpha minus k and then minus 2 being equal to 0. We're just remaining with 10 minutes. Okay, so now let us now find, having found alpha plus beta, let us find now alpha beta. So alpha beta is just equal to c over a. So alpha there, you write it like that. So our beta in this case is alpha minus 4. So while there's beta, we'll put alpha minus 4. Then this is equal to C. C in this equation is 9. Then over C is 9, and then A is 4. So we simplify this side. Alpha times alpha, you get alpha squared. Alpha times 4 there, you get negative 4 alpha. This is equal to 9 over 4. So you can simplify this again further. Or if you don't want to simplify this, before you even do the simplification, I think we make alpha the subject here so that we find the value of k there. So alpha, when you make alpha as the subject in this case here, means that we're going to have k plus 2. Yeah. So meaning while there's alpha here, we're going to replace with k plus 2. So, or actually, if you want to simplify things, I think just find the value of alpha by factorizing this equation. So let us try to do that. So when we multiply through by 4, we're going to have 4 alpha squared. So when we find the value of alpha by factorizing this equation, we just come and put it here, and then we're going to find the value of k. So this is 4k alpha minus, 4 alpha squared minus 16 alpha, then is equal to, this is 9. And then when you take this 9 to the other side of the equal sign there, you're going to have 4 alpha squared, then minus 16 alpha, and then minus 9 being equal to 0. So here's just a matter of solving this quadratic equation. When you find the roots of this quadratic equation, those are the values of alpha that you have. So meaning, having found those values of alpha, you come and test them. You come and put them, you come and plug them in this equation. So let us try to find what is the factor and what is the product. Or maybe in order to do it, I'm sure most of us can find what I'm trying to say here, because it's just a matter of factorizing this. You can use the completing the square method, you can use the formula method or factorization method for you to solve this. Then come and plug it in this equation here to find the value of k. And then to find the equation, just take back the value of k, put it there, and then you find the answer. So I think you finish it as your exercise. Let me do the last question in the remaining 6 minutes. So here we have 2x squared minus 3k x plus 5 being equal to 0. And the statement here is saying it has one root which is twice the other. Meaning if our first root is alpha, if our first root is x is equal to alpha, meaning our second root will be x is equal to alpha. So to find our alpha plus beta, you can say alpha plus beta, which is alpha plus beta is negative b over a. So in our case, we have alpha plus. While there is beta, we put negative. We put 2 alpha. So this is what we're going to have. So our negative b there will be positive 3k over our a there is 2. So here what we're going to have is alpha plus 2 alpha, we get 3 alpha, which is equal to 2 over, 3 over 2. Okay. So what you do here, you can make alpha the subject by saying alpha is equal to, this is k over 2. Or rather you can say 2 alpha is equal to k. When you cross multiply there, you have something like this. So now we also find alpha times beta. So alpha times beta is simply just equal to C over A. So our C, according to this equation, is 5. First, let us write our alpha and our beta. Alpha, then we have, where there is beta, we put 2 alpha. Then this is equal to, our C there is 5, and then our A is 2. So what we have is 2, we have 2 alpha squared being equal to 5 over 2. So here what you do is, you can divide everything by, you can divide everything by 2, so that you just remain with alpha squared being equal to 5 over 4. So to find the value of alpha, you just get the square root of this 5 over 4, which will just give you the root of 5 over 2. So now to find the k, you just replace where there's alpha with that. So k is equal to 2 alpha. So our value of k is equal to 2, where there's alpha, we put the root of 5 over 2. So k is now going to be equal to the root of 5. So the value of k is just simply the root of 5. So having found the value of k, let us finish this one since it's just the last question. Having found the value of k being the root of 5, the question is continuing to say write the resulting equation. So now you just replace where there is k with the root of 5. So the resulting equation will be 2x squared minus 3 root 5 x plus 5, like that, is equal to 0. So basically this is the equation. If I've not made any mistake, the time is even up. So mark the questions that I've given you as exercise. I'll send the slide to the group. Anyway, shalom. The meeting is ending in just seconds.